Hello, everybody. Welcome to this QA Innovation Summit 2025. My name is Leandro Melendez, also known as Señor Performo, and today I come to you with a presentation where we are going to be exploring a little bit of the possibilities, stretches, and chances that we are going to get if we start leveraging AI into our performance testing projects. But before we start, I want to welcome you and thank you all for being here at this presentation and in these online conferences. I hope that you are getting the best out of it. Now, back to the topic that we are talking today. As I mentioned, I am going to be presenting today the AI powered performance testing. We are going to be doing an exploration on the possibilities that we are going to have in the performance testing fields thanks to this AI movement that we are getting nowadays in the market. Before we begin, for the those that do not know me, I am Leandro Melendez, again, also known as Señor Performo. I am an online educator. I have been a performance testing consultant for around 15 years. I am a podcast host. If you want to follow, provides in English, just provides or provides en español. I also have a couple of YouTube channels, Señor Performo ENG for English or ESP for Spanish. If you want to, well, polish your skills and your Spanish, not only performance. In this channel, we talk a lot about performance, also QA, also IT, processes, methodologies, and much more. And as well, as you see me here presenting on these conferences, I am a presenter. I like to be on stage either in person or virtually and, well, make a clown of myself, hoping that through that you're going to learn something. So I hope that I deliver the best. Also, I have a book, The Hitchhiking Guide to Load Testing Projects, a traditional step-by-step guide through the traditional load testing projects. But enough about me. What are we going to be talking about today? Well, today on our AI talk, artificial intelligence talk, no, I'm a real person, I'm not an artificial intelligence, but we're going to be dividing this presentation in main topics. First, we're going to go through the needs that we are going to need for embracing performance testing or AI on performance testing. Then we are going to go around how can AI assist us on designing performance tests. After that, we're going to go through the creation of performance tests, a little bit different from the design process. After that, we're going to check how can we get assistance from the results analysis in performance testing. And in the end, we're going to check on some predictability capabilities that we are going to gain through these technologies, and as well, a little glimpse into the future that is coming into performance testing and AI. So let's begin. First, let's dive into the AI needs. What does AI needs to work well with performance testing? Because believe it or not, it's not just about having the LLM or having some machine learning engine or some assistant or some GPT plugin API or something enabled in your solution. We need a few more things to truly enable and embrace AI in the performance testing realm. So, to begin, AI alone often is wrong, and I don't want you to get worried about this statement. But AI, in its all its different presentations, depends a lot on how it has been trained or what is the information that you are providing to it. And this doesn't go only along if you're a good prompt writer. No, it also has to do with the information that our AI engine, LLM, ML, whatever flavor or type we are talking about, it's very dependent on the information that we provided. On top of the usual hallucinations, AI is not an exact technology, it's not always going to give you the same or exact answers, which can have some slips here and there, which I'm going to show you right now that I got a very weird situation right away, starting trying ChatGPT with some requests for performance testing. I just asked ChatGPT, hey, I am about to start a performance testing effort for my project. It will be released soon. What steps should I conduct to do these tests? And I didn't expect it to go wrong right away. If you don't know me, I have a rant online where I always want, this is kind of my crusade all the time. I want all of the world to understand that performance testing is not the same, is not a synonym for load testing, capacity testing, pushing the system to its limits and trying to bring it down. I want everyone to understand this difference because performance testing is a global practice in which you can do multiple things. You should do multiple things, not only can, and in which you should not do only load testing. There are many, many other things where most of the information that you find online says that you gotta jump right into load testing. That performance testing is used online on all of the information that we have on the nets, saying that performance testing means bringing the system down to its knees, which is not right. Performance testing is a wide practice that requires you to be able to do multiple things. You should implement multiple steps for performance testing. And ChatGPT here is sending me right away into, hey, start defining the objectives, prioritize high traffic, high risk functionalities, and push the limit, right? Here you can see a little bit more of a follow up of the description. First, it wants me to get some objectives and the scope and identify what are the performance metrics, which the prioritization right away goes to load testing, load, full traffic, high risk, gather requirements, load times to be on the this amount of seconds, the thresholds to be able to handle 1,000 concurrent users and things like that, which on so many levels are wrong. If I'm asking just for performance testing, AI is getting it wrong. And why is this happening? Well, this is because on the internet, online, where these models have been trained, only mentions that. Everybody has this confusion online that tells me that probably I should create more content that trains the AI to give a right answer. But again, this is the point. The training that we are giving to the AI is the source of all of these situations. So for that, the AI that we are going to be using, let me move over here, must have good data. Really, really, that's the most important thing. We need to insert, train, or provide good data, good starting points for our AI. The best results that we are going to get are when we give good data to our AI. Beware, all of these can be done in different ways. As an example, we can train our machine learning system using all the data that we have in our solution, our metrics, the behaviors, all sorts of things that we can use. Or if we are working through a prompt, through an LLM, we can provide the LLM all the preferred data, all the needed data inside of that prompt. Again, the best experience that you're going to have is when you have your own data and good data. And why do I mean your own data? Every system is different. Even me, as a human being, when I was on a project and a customer was expecting, just because I was a performance testing expert, that I knew how their system worked, the particularities of the system, which is impossible. So if we don't provide that information to the AI of our particular, if we don't teach the AI to dance as we do in our project, in our solution, in our organization, well, probably we will get generic answers or empty answers or just plainly wrong answers, right? So let's see, once we have good information about our systems, what things can we do for performance testing? So first, we can be aided by AI in test design. We can generate great tests, great types of testing processes, scenarios, profiles, and all sorts of things aided by AI. How can we do this? Well, first, again, we will depart from the data that we have in our system. Because as I said a moment ago, if the data is not available, if we just give generic data to the system, like this customer was just like, hey, you're a generic performance testing consultant, why don't you know how to test my system? And I was like, well, my previous customer was a toy maker, you are a cereal maker, and both of you have processes that are completely different in your systems. Do you want me to test your system as a toy maker? You sell cereal, right? So how would I have known if the customer doesn't give me that information or doesn't give me access to talk to people that have that information, that know how the system works? Well, if I had a hard time knowing, how could the AI know as well? There are some sources of this data. Again, it's super important that we provide correct data to our system, to our AI, so that we can simulate good patterns or good scenarios, good tests in general. Let's say we are thinking on a particular type of load test. We can be aided by this in this data generation, or pull it from, as an example to start off, from an APM. An APM is an application performance monitor or manager. APMs installed in your system have so much information, or are pulling so much information from your system, usually from production, but I highly recommend you to have them on multiple environments, not only production, because from there you will know what is the situation on pre-prod, on staging, on QA environments, dev environments, whichever environments you have. But APMs in production will give you lots of really good information that you can feed to an AI model for it to aid you in modeling what would be a good test. As an example, here I'm showing you a display of the possible information bits that you are going to get from an APM. Here we are seeing what are the APIs that are being called together with their methods, all the situations that we are invoking. And something really interesting here, you can tell that the APM here is telling you what is the originating service that is calling this API. As an example, the API is a post into intake v2 events, which is being called by the APM server. Probably not the best information, but below it, we have an API that gives you orders called by opbeams-go. I mean, this is just an example that I found floating around, but right away we can see that they have some performance issues. I'm stepping ahead a little bit on what is truly important for us at this moment, but you can see who called it, if it's slow, if it's fast, and the traces per minute, or the amount of times that this API has been called. This is super useful. If we ask the AI, hey, AI, I need a simulation for a scenario where you tell me, well, we load the most requested API in our system. So if we quickly do a check here through the readings that we have, how many? Well, the most popular is this one that is getting 30.8 transactions per minute. That's the one that we need to focus first. Then it's the get API here with 19.2, and then 17.4. I'm doing this with my human intelligence, not artificial, telling you that those are the ones that we should focus on. But if we provided all this information, the AI, LLM, or machine learning model would be able to give us information about our system and what would be the most important test, like what can we test. We'll go deeper into that. Another functionality that the APMs have is that since they know they have these traces of the user journeys, where users experiencing, flowing, we can create maps like this one, where we can see that all our users start on the launch page, the initial page. Most of them go to the home page. Some of them go to one called the first activity or others category. So here we have the flows. At the top, you can see the most frequent flows for our users. And then we have subflows, like all the crazy paths that we are our users may go through in the different pages and elements of our system. With this information, imagine providing it to the AI model, like telling it, hey, AI, can you generate, I don't know, the 10 most heavily used test cases? From this information that we get from an APM, we will be able to put together some test cases automatically and really, really quick. The other way that we can also gather this information is to manually implement observability in our systems by getting OpenTelemetry, probably Prometheus clients or Jaeger or many other tools, which in which you will be able to generate on your own databases all sorts of information that, again, if you feed all that information to your AI, either flavor version, whichever you are working, you will be able to ask it very precise things like, say, hey, AI, what is the component interaction amongst my solution? What components are interacting among each other? Or as an example, hey, AI, could you tell me how much, how hard, how many threads or concurrent processes or the threshold I need to call or simulate or generate to do a simulation of, I don't know, a Thursday, an average Thursday at 4 p.m. in my system? And as well, we may get some insights and some information on how to design or what should we take into account where we are having important events happening in our system. As an example, let's say Taylor Swift visits our system, or we're going to sell concert tickets for Taylor Swift, or we have a Black Friday. Some of these big events that probably we have not experienced, but the AI will be able to put together this information and tell us, okay, for Taylor Swift, you shouldn't focus on, I don't know, process A, B, and C. Focus on process sell ticket, process, I don't know, identify special customer, and make sure that those are going to be able to go through, even if millions and millions log in at the same time. Some of these things are going to be much more easier for us to generate if we ask the AI system. And as well, some other cool things that we will be able to ask AI. I mean, not only to give me insights, but hey, can you just create a scenario file for me? Just have everything ready to run. Just create the file, let me check it. I don't know what is the ramp up that you put, how high the load has to be. But for this, to be able to execute these just created tests and automation or indications from our system, well, we need the actual tests, we need the actual automations. So let's move on and see what are the things that we can do with AI when we are working on creating tests. So before we dive into seeing how AI can assist us in creating the tests, creating the automations, making sure that we get to the end with the best possible automations that we can have, we need to do a small differentiation. In performance testing, and as well in many areas of QA, the automations come in two main flavors: the multi step end to end and the service calls or APIs. The multi-step are the ones that we have them recorded in a browser, where in the browser we are going to go to the main screen, then go through the login process, then go to, I don't know, the home screen. In the home screen, we are going to select menu, where on the other side we have the API calls, which are very much more punctual, straight to the API request. I just want to, as we were seeing earlier, I just want to get to the API that gets me the list of all the items or products. Just invoke it, and that's it. So when we are working with the service calls, these AI assistants in API automations, we can get a lot of help, as an example, from copilots. Copilots that we are going to aid us when we are, let's say, hey, what are the main APIs or the requests that I have to automate for my script, my automation? So we will get a support on what are the APIs, which ones should we focus, which ones are, I don't know, missing, the ones that we have to create. Probably we will have access to the database of APIs that we have already automated. And for each one of these APIs, if we mix it with all the APM information, all the instrumentation and monitoring observability information, and pair it up with the code of our solution inside of our AI, we train our AI, again, either an LLM or machine learning. It will be able to tell us the requirements to create those API calls. Hey, you need, I don't know, authentication, you need to provide this type of item, you need to create another process that populates, probably it's a post API that will burn through the data. Okay, you need to create this much data. But this is a simple one. This is a very straightforward one. The biggest challenge, the most entertaining that can generate Stockholm syndromes, if you ask me, are the ones that are end to end. We need a lot of help, either creating these multiple step automations, and we can identify them through copilots. We can be provided automatically these correlations, this parameterization that is needed, tuning the wait times, where do we need to add them, how can we parameterize our automations, or using LLMs with these GPTs. There's a very interesting technique that I have been using that it's pretty good, where we provide the recordings, all the traffic that we recorded when we are creating these multi-step automations. All those recordings, we can provide it to the LLM, provide the script that was automatically generated by our tool, and ask it like, hey, can you provide me the correlations or create them? Tell me where, why are they important? And identify some of the gaps, some of the elements that we should remove or that are not interesting, but we need to provide this. To give you an example, here I was working on a K6 script that I already created from a recording. And I told it, hey, I have hard files for the traffic that was happening while I was creating this recording. If I provide you the hard files, I provide you the script. Can you tell me where do I need to do the correlations? And of course, ChatGPT told me, like, of course, give me those hard files, give me that script, and I'm going to help you. And it helped me indeed. It did. The correlations were pretty good. Again, AI still has some brain farts here and there. So I highly encourage you, be careful. Just don't blindly trust what the AI throws at you. But if you notice, I did here a specific request to it. Give me a couple, I'm going to give you a couple of hard files, two, with exactly the same steps. With this, the AI will have an easier time identifying which parameters are changing from recording to recording so that it knows which ones have to be correlated. If I provide 2 or 3 hard files with different users, with different parameters and different inputs, right away it tells me this is a parameter, this you need to parameterize, this is correlated here, 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 and there. Most of the time, it does a flawless job. So this is how you may be aided by AI while creating your performance scripts. And as we were mentioning earlier, you can be aided when you are creating the scenarios. So let's see. When we have the results in our performance tests, but first, the results from a performance test used as input, this information that we are going to provide to the AI that I was mentioning. All these performance test results that we can provide, the logs, metrics, traces, they can be an incredible input for our LLMs, MLs, all the models, or all the AI flavors that we may want to use are excellent inputs that we can use to them. Once we provide those types of data, because it's not only the test results, as I was mentioning, we can provide not only load test results, but unit test results so that the AI can answer, as an example, this very bad question that I hate when I receive it because there's no absolute answer. Like, hey, what is a good response time for my system? There's no good because not everything should have the same response time. The type of data that we can also provide to analyze results are results not from load tests, but from monitoring. We can also use synthetics. Synthetics are automations that you run continuously at a very, very low volume. It's like just taking the heartbeat of your solution. We can also get pre-production measurements that if those results are provided to AI, We can know, hey, your pre-prod environment usually responds this amount of times slower than production. The dev is even smaller, or maybe it responds better, can help you, like, hey, maybe your database is empty and that's why the response is awesome. And last, RUM, we can also provide real user monitoring metrics. So all this type of information we can provide to the AI models, LLMs, machine learning, all those things, so that it can help us with all awesome findings. As an example, it can tell us like, hey, you have a bottleneck here, and it can do some correlations similar to not the script correlation, but telling us, hey, when you click here, the database gets loaded up here, and I don't know, your network card gets piled up, and that's your bottleneck. It can help us to identify bottlenecks on load testing projects. And as well, it can help us a little bit like, hey, your bottleneck is because, I don't know, you don't have an index on your database. As well, it can help you analyze patterns, like saying, hey, a month ago, you had, I don't know, 20% less activity. 2 months ago, it was 30% less. So I have been noticing that month by month, your activity is increasing. Probably next month is going to be like this. Be ready. So it can help you prepare for upcoming patterns, upcoming situations. And as well, something that many performance engineers drool for are performance reports. AI can help you generating performance reports. Personally, I don't recommend you to just blindly trust these reports and pass it to management or whoever is asking for the reports, but they are a very good starting point so that you get an idea on what is going to happen. Now, as well, AI, as we mentioned, will help you in predictions. With all this information that we are providing AI about our system, the development, continuous development, maintenance, use, or upcoming situations, we can figure out some upcoming issues. As I was mentioning earlier, AI can give us some insights like, hey, I noticed that your utilization is growing little by little here, here, and here. So maybe you should be prepared because when we hit this point, maybe your database will, I don't know, stack up, you will run out of memory, out of available pods that you can. So all sorts of issues that can come in the future. And as I was mentioned earlier, it can help us in modeling future scenarios. On one hand, if our system is evolving and we are getting more users or more activity or less users or new areas are becoming active in our system that in the past were not. And as well, we may be able to simulate or analyze what would be the best chaos exercises, chaos testing, chaos engineering. And now we're getting close to the end. I want to close up a little bit with some future predictions. I think, and I foresee, first of all, that we are not ever going to have one single tool to do all the performance, everything with AI and analyze all the possible things that you can do. Probably not. Just that during this presentation, I mentioned you can use ML, you can use models, you can use prompts, you can use GPTs, generators, multiple different flavors of AI, and don't expect that one single thing will come and make everything for us. And because all of these, humans are always gonna have to be involved on the performance testing efforts. I don't think there's any way in which we can take the human out of the equation. But well, that was it. I hope that you enjoyed, that you learned a lot, that you saw some of the possibilities of the things that we can nowadays and we will be able to put together around AI and performance testing so that you become a better AI assisted performance engineer. With that, I leave you here the QR code if you want to reach out to me, like, subscribe, activate the bell, leave comments, or really just ask me a question. If you need some help, if you need some assistance, some consulting, let me know. I'll be super happy to help you. And with that, well, thank you very much for assisting to this presentation. And let's get on with the questions. Adios.